Okay, I will start with the class. So the third problem. Yesterday, two problems we had solved. Okay, we have to check whether it is an equivalence. So we had checked for reflexive, symmetric, and whether it is transitive type. Okay, so which we had done was for parallel lines and for congruent triangles. Now this is we have to check for perpendicular lines. Okay, so first we have to check with itself. Always for reflexivity, it will be what? L1 comma L1. Okay, so instead of L2 we have to put L1 and check. So is L1 perpendicular to L1? Can a line be perpendicular to itself? No, it can be parallel to itself, but it cannot be perpendicular to itself. Okay, so how we have to write is every line L1 is not perpendicular to itself. Okay, so obviously it is not satisfying that condition. So that's why L1 comma L2 L1 again is not belonging to this relation. Therefore, not reflexive. It should satisfy when you put this as L1 and L1, it should be holding true, but this is not true because it cannot be perpendicular to itself. For parallel, it was holding true, that's why it was reflexive. But now it is not satisfying that condition, that's why it is not reflexive. Okay, so this was for the first one. Now for symmetric, we have to check if it is holding true for L1 and L2, then we have to check whether it works reverse. Okay, so if L1 is perpendicular to L2, this means perpendicular. If you want to write, you can write like this. What will it imply that? Obviously, if L1 is perpendicular to L2, then obviously L2 is perpendicular to L1. So it is true over here. Okay, so it is holding true, no? So you have to reverse the numbers and see for symmetry. Okay, whether it is symmetric or not. Try first with L1 comma L2, then reverse and see, and it is holding true. Okay, so therefore L1 comma L2 belongs to R, implies that L2 comma L1 is also belonging to R. Therefore R is symmetric. Anybody who has not understood these two steps can ask. Okay, then you have to check with 3 lines now. So you can assume let L1 is perpendicular to L2, and you can also say if L1 is perpendicular to L2, and L2 is perpendicular to L3. Okay, so now which we have to check the condition, L1 comma L2, L2 comma L3, then actually L1 should be perpendicular to L3. We have to check whether it is holding true or not. So as per condition, what did I assume? What did I say? L1 is perpendicular to L2. Okay, and what I'm saying, L2 is perpendicular to L3. Now it should hold true for L1 and L3. But is L1 and L3 perpendicular? What is happening? If you see, L1 and L3 becomes parallel. Okay. So what you have to say, does not imply. L1 is perpendicular to L3. Okay, so it is not perpendicular. So you can say does not imply that L1 is perpendicular to L3. What is it happening? L1 is turning out to be parallel to L3. So that's why you write L1 comma L2 belongs to R, L2 comma L3 belongs to R, but L1 comma L3 does not belong to R. L1 and L3 is not perpendicular, so that's why you should say does not belong to R. Therefore, R is not transitive. Okay, L1 is perpendicular to L2, L2 is perpendicular to L3, but L1 and L3 is not perpendicular. So not means you have to put not belonging to that relation, not transitive. Therefore, not an equivalence. If it has to be equivalence, it has to be reflexive, symmetric, as well as transitive. So it will not be an equivalence relation. This is exactly the definition of transitive. If you see A1, A2, A2, A3, then actually it should have been A1, A3 should be belonging to R. But if it is not belonging to R, that means it is not transitive. Next one. Two it is, not Z. This is 2. 2 divides A minus B. 2 divides A minus B means it is nothing but A minus B is divisible by 2. It means the same. 2 can be divided by A minus 2 divides A minus B means A minus B is divisible by 2. You can write like this also. It means the same. Okay, or even the question if it is asked, prove that A minus B is even. Even means what? It should be divisible by 2. So it may, whichever way the question is asked, answer, the solution will remain the same. Okay, now R is a set of integers. Z it is given to you. So solution, you can start like this. For every A belonging to Z, or even if you forget to write this, no problem. Okay, so for every A belonging this, now first time what we have to check, always it is given as A comma B. For reflexive, what you have to do, instead of B, what you have to try, A comma A, no? For reflexive, always same, A comma A. So instead of B, what you have to substitute, A and C. Okay, so for every A belonging to Z, I'm trying for A comma A. So what it will become, A minus A, which is 0. So obviously 0 can be divided by 2. 0 divided by 2 will be 0. Okay, so that's why A comma A. Okay, first time you have to put where A comma A and C and whether it is satisfying this condition. So you instead of B, I have to put A and C. Answer is turning out to be 0. 0 is divisible by 2. So it is holding true. That's why R is reflexive. Even if you forget that, directly at least start with this. Try A minus A is equal to 0 is divisible by 2 and then at least write this even if you forget to write this. Okay. Now second one. Now what we have to check, if A minus B is divisible by 2, whether it's reverse, B minus A is divisible by 2. So it is obvious, no? If A minus B is divisible by 2, then B minus A will be how much? Same thing it is, no? Minus of A minus B. Even if you don't write let, okay. Implies that you can say. Implies that B minus A is divisible by 2. Correct, no? Just give a try. If 8 minus 4 is divisible by 2, means what? 8 minus 4 will give you how much? 4. 4 can be divided by 2. Then obviously 4 minus 8 will be how much? Minus 4. Still you can divide it by 2. Okay. So it is holding true for reverse also. Therefore, A comma belongs to R implies that ulta is also working. Therefore, R is symmetric. Now, third one will be for 3 numbers. So third number you will have to introduce. So that letter you can take as C then. Okay. So what you can assume? Let A minus B. Okay. Or you can write like this first. A comma B belong to R. B comma C also let it belong to R. Means what? Let A minus B be divisible by 2. Let B minus C also be divisible by 2. See, I am introducing a third number now because we have to check for transitive. Symmetric means what? A comma B, B comma A. And transitive is A comma B, B comma C. Then we have to check whether it works for A and C. Okay. So what you can write is, if A minus B is divisible by 2 and B minus C is divisible by 2, then what we have to prove? To prove A minus C is also divisible by 2. Again, I'm repeating this. 3 numbers we have to check now for transitivity always. So the 3 numbers will be A, B and C. So now A, first it will be A minus B. This you are assuming. If this is divisible by 2 and B minus C is also divisible by 2, then it should hold for first and the third, last one. Okay. So how to check is whether A minus C is also divisible by 2. Now I want to check whether A minus C is divisible by 2. Okay, so A minus C I have to express in terms of B. So just write here A minus C, I'm writing separate. Just see what I've done. A minus C, same it is. Okay, I have to check whether this fellow is divisible by 2. So just split this and write it at the side. Now, do some balancing here in such a way that you get these numbers. What is that? A minus B and B minus C. Okay, so what you have to introduce in short, if I want A minus B, I will introduce minus B and plus B. Okay, so I've balanced this. So you write at the side and keep balance minus B plus B. Why am I doing this? I'll tell you. Now this became one number, this became one number. So obviously you have told that A minus B is divisible by 2. B minus C is also divisible by 2. Means what? This is an even number and this is also even number. Even plus even together will give you even only. And obviously if A minus C is even, it will get divided by 2. Okay, so I have to prove that A minus C is also even. A minus B already you are saying is even. B minus C is also you are telling it is even. So I have to check whether A minus C is also even. So A minus C, just split it like this, balance. So obviously you know that this is even. Even number plus even number will give you even. So you know that obviously if A minus C is even, it will get divided by, therefore divisible by 2. Okay, so now you know it holds true for A minus C also. Mute the phone. Whoever is not muted, please. Okay. Therefore, A comma B belongs to R. B comma C belongs to R. Implies that A comma C is also belonging to R. Therefore, it is transitive. Anybody who has not understood or some doubt can ask. Okay, since it is all three, you can write it as a equivalence relation. Okay, then one more we will do, you will understand it better, that is divisible by 5. Same we have to repeat how we have done for divisible by 2, same we have to do for divisible by 5. So fifth one is this, all you don't have to worry y belonging to n. So main condition is what? You have to check whether x minus y is divisible by 5. Okay. Same thing you have to repeat. Now it is x comma y instead of a comma b. So first time what you will have to check? X comma x. Okay, for reflexive. So for x comma x, you know that you have to, instead of y, you have to put x and check. So simply you have to write for every x belonging to which is been given to now, n is given. Okay. So instead of y, just put x and see. X minus x is equal to 0. Obviously 0 is divisible by 5. Okay. So now it is holding true. That's why x comma x will belong to R. Therefore it is R is reflexive. So this is the first condition. Always put the same letter and check whether it is holding true. Second one, what you have to do, check if x minus y is divisible by 5, then whether y minus x is divisible by 5. You know that obviously, even if you reverse it, it will be minus answer, but still you can divide it by 5. So straight away you can write, okay, if x minus y is divisible by 5, okay, later on you'll write proper divisible and all. Divisible by 5 implies that ulta y minus x is also divisible by 5. Therefore, if x comma y belongs to R, implies that ulta also is working out. Therefore, R is symmetric. Okay, so these two are simple enough. Check for the same number, then check this, reverse the same equation Instead of x, you have to put y in this and check whether it is true. Then write symmetric. And now for transitive, introduce a third number. That would be like you can take z. Then you check if x minus y is divisible by 5, y minus z is divisible by 5, then whether x minus z is divisible by 5. Same way you have to do like previous problem only, that same balancing. These two steps, still anyone having doubt, please clear it out now only. Okay, so we'll write for transitive. So you can assume that let this be true, x comma y, and one more you are introducing now, no? Okay, so what you have to do is, now you are assuming if x minus y is divisible by 5 and y minus z is divisible by 5, then what you have to prove that? Then you have to prove that x minus z now. Also, then we have to prove that x minus z is also divisible by 5. We just introduce this. So now x minus z we have to show that it is divisible. So as per the previous problem, x minus z, write it separate. Okay. Now I have to express in terms of these numbers. So what letter is missing? Y is missing. So just balance it, minus y plus y. This number is divisible by 5, you know that. This number is also divisible by 5. So when you add two numbers which are multiple of 5, means consider if this number was 10, it could be divided by 5. Consider this number was 15. Still it can be divided by 5. And if you add both numbers which are divisible, obviously you'll get a multiple of 5 only. 10 plus 15 will give you 25, which can be divided by 5. So anytime two divisible numbers if you add, you will get same number which can be divided by 5. You don't even have to check it. Directly you know that. Okay. Up till here you can directly write. No need to even write this. This balancing is important. Huh? And then you can write, therefore, x minus z together. This is for your understanding. Therefore, x minus z is divisible by 5. And write the final statement. What will be the final statement? If x comma y belongs to R, y comma z belongs to R, implies that x and z is also true. Therefore, transitive. So the steps are fixed always. For reflexive, check with the own number, meaning the first letter x comma x, then symmetry x comma y, then it should hold true for y comma x. And transitive, three numbers x comma y, continuous y comma z, then it should hold for x comma z. So if you have understood this, that means you have understood this part also. Okay, next one. A plus B is even. You can start attempting. First, you have to find A comma A. So instead of B, put A. Again, I'm asking for the last time. Anyone who has not understood this can ask me to repeat. I have some super smart students, everybody. There'll be some who will be dozing, will not even know what is going on. Some will be knowing that they have not understood but don't know what exactly to ask. Anyway, that's your loss if you're not ready to ask. Next one. Okay. You don't have to worry about all these things. Just what is the main condition you check. You have to show that A plus B is even. You have to check whether it is reflexive, symmetric, and transitive. So as per that, first time we have to check for A comma A. Okay, you know that. So for every A belonging to Z, you can say this letter given is Z. Now what you have to put, I told you, instead of B also, you have to put same A only, because instead of B I'm taking as A. So here A. So how much you will get? A plus A is how much? 2A. So 2 into any number obviously will be an even number. Whenever you multiply any number by 2, it turns out to be an even number. Or in short, what, this can be divided by 2. So you know that it is even. 2A is even. That's why it is holding true. Therefore, A comma A will belong to R. Therefore, reflexive. Belonging to R means this, this is a relation. What it means is it is holding true, that this condition is true. Then check for symmetry. Obviously, if A plus B is even, then B plus A also will be even. It's like 4 plus 8 is 12. Then 8 plus 4 also will get as 12 only, So you know that it is going to hold true. So it is symmetric. So if A plus B is even, implies that B plus A is even. Therefore, A comma B belongs to R, implies that ulta is also working out. Therefore, R is symmetric. And then for the third one, so this you have to assume, no? First, A comma B belong to R and B comma C belong to R. Third number I have to introduce. So what you have to do now, it means what? If A plus B is even and B plus C is even, what you have to prove? to prove okay. So this is what we have to prove. These steps will be fixed on. Like this you can write. And then a plus b is accordingly you have to change. If it says divisible, then you have to say divisible. If it's x, y, x, y, z, same, only letter difference it will make. But whatever you are framing will almost remain the same. So now we have to show that a plus c is even. Again, some balancing will be required. So you have to express a plus c in terms of these two numbers. Like last time there was minus, no? Now what will happen? A plus c has splitted this. Okay. Now what do I need? A plus b. Okay. But if I write, now see, if I write minus b, what is going to happen? I don't want minus b plus c. I want it as what? Plus only. So one more plus I want. So total how many? 2 plus I have introduced. So balance it up. Minus 2b. Okay, you can write it at the side like this. Why have I done this? Because I want exactly a plus b and b plus c. In the previous problem, it was okay. Why? Because it was 1 plus and 1 minus. So 1 plus, 1 minus I introduced. But here, I want both plus only. So that's why 2 plus. So since I've introduced 2 plus, I have to balance it by 2 minus. Now if you notice, this is even. I have assumed that a plus b is even. B plus c is also even. And 2 times any number is also even. So all the numbers are even. And if you do any kind of operation using only even numbers, answer will be even. Consider this was 10, 8, 4. So you will get even number only. 10 plus 8 will give you 18 minus 4. Still you will get a even number. So if all the numbers are even, you know that a plus c is even. Okay, so in short, you have to remember that a plus c, you have to balance in such a way that the other two numbers according to balance by that how much whatever you had introduced, and all will be even. That's why a plus c is even. So you have proved that a plus c is even. So therefore, if a comma b is belonging to R, b comma c is belonging to R, implies that it is holding true for this also. Therefore, transitive. Therefore, it is an equivalence relation.
So can you repeat that step again?
Which one? Third one?
Yeah.
Okay. Now we have to show that it is transitive. So as per the question, always third I've introduced. Third number will be C. So it is like A B, C. For reflexive, you have to check with itself. For symmetry, you have to check among itself. A comma B, B comma C. Now for transitive, you have to check if A and B is true, B and C is true, then A and C also it should work out. Now what is the question given? You have to check for even. Now these two you have to assume, correct? The first one's always you know that it is even. So now if A and B is even, because you have already said it is belonging to R. A and B, you know it is even. B and C also you know it is even. Now your aim is to prove that it is holding for this also true. That A plus C also should be even. This is my aim. So now how to prove? I know that these two are even. So express A plus C in terms of these two numbers. So A plus C, what I have done is just write these two separately. Okay, it's the same number A plus C. I just written C at the side because I want to balance something. Now write in terms of this. What is there at the side of A? B is there. So I introduce plus B. So anytime I introduce B, you can balance it with minus B at the side. Now, if you notice, there's another plus B required. It is not minus. Otherwise, if this was minus, I could have simply written this as minus over here and my aim would have been over. But now this is not minus. I need plus. Okay. So this is anyway, this one's balancing. One more B, because it is here, I need one more B I am introducing. So for this, another balance. So minus B will give you minus 2B. And all are even numbers. This is an even number from here. You know that B plus is also even number. And 2 times anything will obviously give you even. So all are even means your answer will also be even. What is the answer? A plus C. So A plus C is even. Understood?
Yes, teacher.
Then this is the final statement which you have to write, and then it is transitive. Next one, seventh one is x comma y related to u comma v if xv is equal to yu, so that r is equivalence relation. Okay, if x comma y is related to u comma v, if this, okay, if the answer is this, then show that it is a equivalence relation. Earlier we used to solve problems only with a comma b. Okay, now these are like two pairs inside of this. Okay, how we had a comma b, no, like that it will be now. Related means x comma y comma u comma v. It will be something like this. Okay, it means the same as this. So now we have to check. So how they are related, look at this equation now. What you got, how these two are related. The first one is related to the last one. And this. Have you seen? X and V, Y and U. Okay, so this is the relation they have given. Now we have to check whether it is equivalence relation. Now this is like only one letter. This is like a second letter now. So you have to take in terms of pairs now. Now we have to check for reflexive. Okay. Now for reflexive condition, what you have to do is earlier. Okay, this I will tell you. If x comma x was there, no, it also meant as x related to x. Okay, it means the same. Now over here, this is one pair. This is like a whole x. This is like a and this is like a B, you can write. For reflexive, I will have to check this pair again. X comma y, x comma y. This means for reflexive. I'm checking for reflexive. It is in terms of pairs now. They are not separate letters. So this is A. So in short, I'm finding A comma A. This is like A comma B. For reflexive, what I'll have to find? A comma A. So the whole pair, instead of U comma V, I have to take the same pair, X comma Y. And just put here now the relation. So what you will get, how they are related, I told you. First and the last, okay? First and the last, second. Okay. So this, according to that relation, what you will get? X into Y will be equal to Y into X. So is it equal? Yes. So it is true. Okay. So only thing here is, this is like a first letter. This is like a second letter. Whenever they give like this two pairs, first and second letter. Okay. So for reflexive, what it will be, take the same pair again and try the relation same way. How they had given you exactly. First and last is related. This is related. This is what they have given you. So when you replace, instead of U, what will come? X will come. Instead of V, Y will come. And then accordingly substitute and see if both the left hand side and right hand side is coming equal. It is coming true. Therefore, X comma Y is related to Y comma X. It means the same thing, belongs to R. Therefore, R is reflexive. Okay. Please assume this as one letter. This is like one letter and this is one letter. So this is your first letter A and this is B. So for reflexive, we have to find A comma A, means first pair with first pair itself. Then we have to check for symmetric. Symmetric is what? If this is this, now you have to exchange the pairs. U comma V will come first, X comma Y will come second for symmetric. Okay, so you know that this is what first what is given. X comma Y is already related to U comma V. Okay, so what it gave you? XV is equal to YU. Now check for ulta. U comma V. Okay, how we used to check for symmetry? A comma B, then you have to check whether it is holding true for B comma A. So this is like A comma B and this is like B comma A. I'm trying reverse. So what is the relation? First and last. this and this. Same, I'm following a pattern. So u, y, okay, will be equal to vx. So is it the same thing? Right beside. Okay. Or yu is equal to xv. Writing x with this side, yu this side. Both the answers are same. So therefore, it is symmetric. Even if you exchange the pairs, if you write the second pair first and first pair second, you are getting the same answer. Anyone having doubt? Again, I will repeat. Reflexive, same letter. Okay, first pair only 2 times and then find the answer. Symmetric, first already they have given, this is a comma b, answer is this, that they have given. Now exchange and see the pairs, write the second pair first, first pair second, and try the same pattern and see if you are getting the same answer as first one. So you are getting both the answers same. That's why it is symmetric. So how we will write? X comma y related to u comma v. Okay, implies that u comma v is also related to x comma y. Okay, therefore symmetric. Both the answers, even if you reverse, answers are coming same. That's why it is symmetric. And now for transitive, you will have to write third new pair. Any other letters you can take other than x, y, u and v, any other pair. So it's like first pair, second pair and now third pair. So this is already the first one, and u comma v are some new letters I'll have to introduce. I'll use a comma b. This is like first pair, second pair, okay, and this is the third pair. So if first and second, second and third, then you have to prove that it is holding true for first and third. Okay, so then to prove that x comma, what you have to prove, this is related to last one. So what actually should be the answer, which should be turning out this and this, no? So xb should be equal to y, should be your answer. So you have to prove that your answer is x into b is equal to y into a. This is what we have to prove. So now to prove this, take the first relation. So what was the first relation? X comma y or u comma v. Now from here what you will get? This, no? So xv is equal to yu. So this is your equation 1. Same way, write the second relation. u comma v are a comma b. Same way, same pattern you have to try. This will give you what? ub is equal to va. So this is the second equation. And from this two, you have to get this. So what you do is multiply equation 1 and 2. So when you multiply equation 1 and 2, you will get xv into ub, which is equal to left hand side into left hand side, right hand side into right hand side. Now cancel whatever is getting cancelled. U and U will cancel, V and V will cancel. And what it get is xb is equal to y a, which is nothing but you have proved. Okay, so again I will repeat. See, these are the three pairs. So which are the first pairs given to you? These two pairs are already given. X comma y is given to you. U comma v is given to you. Now what you have done is introduce the third pair a comma b. So what you have to prove, if this is related to this and second is related to third, then first and the third one is also related, you have to show, correct? So that's what I'm trying to do. So what I've done is let first and second be related and second and third be related. Now what we have to prove, that the first and the third one is related to each other. That is what, according to the main formula which they have given, this into this, x into b should be equal to y into a. This is what you have to prove. Okay. So obviously you know this relation from here. So now use the formula here. So what it will be, the same thing I've written here. So x into v will be equal to y into u. So we'll get the first equation. Same way use this also relation. Okay, so u into b will be equal to y into a. So that will be the second equation. Now using these two equations, you have to get this answer. So what you do, just multiply these two equations. So left hand side will get multiplied to left hand side, right hand side will get multiplied to right hand side. Then cancel whichever letters are same on both the sides and you will get this answer. And which is that you have proved. Okay, so last statement you write. So if x comma y is related to u comma v and u comma v is related to a comma b, implies that first and the third one is also related. Therefore, transitive. And hence equivalence relation. Anyone having doubt? Next one. Find its reflexive, symmetric and transitive. Okay, we have to check whether it is symmetric, reflexive and transitive. Now, and they have said it is a natural number. Okay. So now, first we'll check for, now there are only two this. So first time we'll have to check for x comma x. Instead of y, again it will be x. So as per that, what you will get? So x is equal to x. Instead of y also, y will be equal to nx. Okay. So for what it will hold true, x should be equal to x. So n is a natural number. So only for one number it will hold true. Only when n is equal to 1, put any natural number, listen see. So what you will get when n is equal to 1, x will be equal to x. Okay, so at 1. So at n is equal to 1, r is reflexive. If you put any other number, it will not hold true, if you see. Okay, so if you put 2, x will not be equal to 2 times x. So you just have to specify n is equal to 1 only. Okay, so r is reflexive. So first what I have done is I've checked for the same letter. So wherever there is y, I put x. So x is equal to nx. Actually, it should turn out to be equal. When it turns out to be equal, when n is equal to 1. So at n is equal to 1, r is reflexive. Okay. Now we'll check for symmetric. Want to write this on? This I had not written now. At n is equal to 1, x comma x belongs to r. This you write. Now for symmetry I'm checking. So now let x comma y be equal to r. So first, what is given for x equal to r? Y is equal to nx. Now we have to check the ulta side. So now y comma x belongs to r. So what you will get? Ulta. Reverse you have to check now. X will be equal to ny. Okay. In both the equations should turn out to be same. When it will again turn out to be the same? Only when put n is equal to 1. When you put n is equal to 1, y is equal to x, and x is equal to y, then it is turning out to be same. If you put any other number, it will not work. See, y is equal to, if you put 2x, and here what you will get, x is equal to 2y, which is not the same. Only for one number it works, when n is equal to 1. Okay, so in both places, if you put 1, answers will be same. Y is equal to x and x is equal to y. So at n is equal to 1, x comma y belonging to R implies that y comma x belongs to R. Therefore, symmetric. And now the third one, transitive. So you'll have to introduce another letter, Z. So then X comma Y belong to R and Y comma Z belong to R. Now to prove X comma Z belongs to R. Okay, X comma Z belongs to R, you have to prove. So what all is given? First one, X comma Y belongs to R means what? Y is equal to NX. First equation you will get. Then Y comma Z belongs to R means instead of Z what will come? Here Z is equal to NY. Okay, and now you have to use first and second equation and prove this. Okay, so put value of Y from 1 in 2. Why? I want in terms of X and Z as the answer. Okay, this is Z and Y. Instead of Y, I can put this value. So what is value of Y? Nothing but NX. So Z will be equal to, instead of Y, I'll put NX. Okay, so how much you will get? Z is equal to N square X. And now put N is equal to 1. And you will get Z will be equal to X. Here also if you put 1, Y will be equal to X. And if Z is equal to Y, then X is equal to Z. 1 square will be 1 only. So that's why you'll get Z is equal to X. So you have got the answers. Y is equal to X, then Z is equal to Y, then Z will be equal to X. Therefore, if X comma Y belongs to R, Y comma Z belongs to R, it implies that X comma Z belongs to R. Therefore, transitive. Okay, and therefore will be, so you have just find whether it is reflexive, symmetric and transitive. So at n is equal to 1, it is reflexive, symmetric and transitive. Okay, and the last one. So we have to prove that this is neither reflexive nor symmetric nor transitive. Okay, so the one more thing what we have noticed till now over here is that we've always asked to check whether it is symmetric, reflexive and transitive. But whenever you ask to already prove that it is not neither reflexive, means what you have to show that it is not reflexive, not symmetric and not transitive. Okay, so whenever you want to prove that, you have to give one example. Okay, give any one example which is not holding true and show that it is not reflexive. So what we have to do is first to check for reflexive, same letter now. So first we'll check for x comma x. Okay. So instead of this formula, instead of y, what will come up? For x comma x, what you will get? X less than equal to x square you will get. Okay, because x comma x for reflexive. So wherever there is y, it will be replaced by x. Now just try to put any numbers and see if it is holding true. We'll start with 1. If you put 1 here, 1 is less than 1 square. Then if you put 2, 2 is less than 2 square. Okay, so if you try to put all the numbers, natural numbers, what is happening? It is holding true. But now in the question, what has been asked? Show that it is not reflexive. So you have to give one example which is not holding true. So, but if you are putting this numbers, it is actually turning out to be true. Now, just give a try with a fraction and see. This will not work, means this side. So just try, let put x is equal to half NC now. You can take any number because they have said x will belong to real numbers. Any fraction, anything you can take. They have not said specifically natural numbers. So just put half NC over here, both the places, and check whether it is holding true now. So when x is equal to half, what you will get, this side will be half. Okay. Any fraction you can take. I've just taken it as 1 upon 2. So this side what you'll get? So is half less than 1/4? If you are given half something, half apple, and if it's 1/4 apple, so which one will be this? Is half apple less than 1/4 apple? No. Okay, so it is not true. So it is not holding true. So you got one example which shows that it is not satisfying this formula. Okay, so one example is enough to show that it is not holding true. So half is not less than 1/4. Therefore, x comma x does not belong to R. So it is not holding true for this number. Actually, it should have been holding true for all the numbers possible. But you gave one example where it is not holding true. So therefore, R is not reflexive. Anyone who has not understood, please ask. I can repeat. You have to try with different numbers, okay, and check whether it is holding true or not. So always whenever it's something like this square, cube and all, no, always take a fraction as an example. Next time whenever you come across here, if it is a cube, still you just take a fraction. If you try with natural numbers, I had told you, it will never work, it will always work out true. But I want to give an example which is not true. Why they have told that to show it is not reflexive. That's why take always a fraction and you will always get not true. Because you can write here for your understanding, half is not less than 1/4. It is greater than. Okay, that's why it is not holding true and not reflexive. Okay, same way we have to check for symmetric. Symmetric also we have to give one example, okay, which is not holding true. So let x comma y belong to R. So take any two values now, x and y. let x be equal to 1, y be equal to 2. Any numbers you take, okay? Let x be equal to 1, y will be equal to 2. We have to try both reverse. One time with x comma y and one time with y comma x. So we'll try for x comma y first. So as per that, it will be the same formula. So just put this values. 1 is less than 2 square. So this is true. But the same thing should work reverse also. It should turn out to be true. Then only it will work. Okay. Now for y comma x. Okay. You can directly. So y comma x, what will happen? The formula will reverse now. Instead of x, y will come, and instead of y, x will come. Now put the values and see. So is 2 less than 1? No, not true. Okay. So I've shown that if you reverse, it is not holding true. 1 is less than 2 square, but 2 is not less than 1 square. So it is not symmetric. It is not working for the reverse order. X comma y is true, but y comma x is not true, is not belonging to R. Therefore, not symmetric. Any doubts in this? Okay, there will be for transitive, which will have to take 3 numbers, x, y, and z. So let x comma y belong to R, y comma. Okay, then we have to check whether it works for x comma z. So 3 numbers. So let x, some values I'll take. X is 3, y is -2, and z I'll take as -1. Okay, I have to give one example to show that it is not transitive. Means what? It should first, this should be true. This also should be true, but the third one should come out to be false. Means not true. Now we'll try for the first one for x comma y. So for x comma y, what will be the formula? X is equal to less than y square. So just put the values. 3 will be, so how much is this turning out to be? 3 is less, -2 the whole square will be +4. So it is true. Okay. First 2 should be true. Huh? The third one should not be true. Then we'll check for then y comma z. So as per that formula, what you will get? Y is less than z square. So now put the values. -2 is less than. So obviously -2 is less than 1. So that is true. Now third one should not be true. Which is that x comma y comma, then this x comma z. Now put the values and see whether you are getting. whether it is satisfying the condition. If it is not satisfying the condition, means it is not transitive. So as per that, this will be 3 z square. Is 3 less than 1? No, not true. So that's why x comma y is true, y comma z is also true, but x comma z is not true, therefore not transitive. So whenever you are asked to prove not something, not reflexive, not symmetric, give example with numbers. One example is enough, ensure that it is not transitive. And when it is asked to prove reflexive and all, you cannot give examples with numbers. Huh? Only when you are asked to prove not transitive and all, like this you can do and show that it is not transitive. So we'll stop here, but I'll take attendance. Okay, so those who have finished can leave.